And we are ready to start. Good evening, good afternoon, good morning, everyone. Welcome to our today lesson. In this class, we're gonna do next part of our infrastructure. To be more precise, databases. Modern applications do not work without databases. Database is usually go-to storage for user data, for persistent data of the application. And what we're going to do today is create a database. We will use Amazon RDS. We will create a separate module and integrate it into our infrastructure. I will create a branch and start coding. Similar to what we've done previously, we'll first create, I would say, main module structure. And the resource we're going to use is called AWS RDS or AWS DB instance. I will specify all the options that we need, and after that we'll go through them and discuss and explain, if you don't mind. Okay, very cool. So identifier is the name of our database. Allocated storage is amount of gigabytes in hard disk for our database. Engine is type of our database. It can be MySQL, it could be Postgres, Oracle, MS SQL, any modern database engine. Instance class, similar to instance size in EC2, how large and what type of instance it should have. Name of the database, it's like a database level object inside the instance itself. Username for database, password for database, multi-AZ, this will automatically put the database instance into different availability zones, create 2 replicas, and create some sort of like load balancer, let's say. And each read and write, each write to the database will synchronously happen to multiple endpoints, to multiple instances of it. So database will automatically be highly available. Subnet group, database subnet group is basically an abstraction that allows to specify which subnets are used by this database. Security group will create security group later. Backup retention period, how many days we should store our backups, when should we take our backups, and this option is very important, don't miss it. Skip final snapshot means when we destroy this database, it will not create a snapshot. Otherwise, Terraform destroy will hang for a while. So I'd suggest you keep it to true instead, at least in the test environments. So let's create database subnet group and the security group. Um, let's have it more secure. Pretty simple. We've done this millions of times already. The name to which VPC it should go and which port should we open. 3306 it's default MySQL port, and we will pass security group ID of our autoscaling group, so that instances in autoscaling can communicate with our RDS instance. And also AWS subnet group. So what is doing? Basically, it's an abstraction that groups several subnets that we pass as a variable into this module into something that can be consumed by RDS instance. And here we just specify the name of our DB subnet group and the ID of our security group as well. Let me copy paste it. Let's declare our variables. We no longer have RDS password. Yeah, let's declare a RDS password as a variable as well. So here, instead of directly hard coding, it will be as a variable RDS password. And in level 2, let's declare one more file called rdstf and call our module from it. Yeah, we don't yet have this locals. Super secret password. So pretty standard situation, yeah. We've created our resources. AWS RDS in this case is just a resource with couple of options. As usual, you can find more references in Terraform documentation if you search for AWS DB instance over there. Uh, it has security group, it has special RDS related resource subnet group. We've declared a bunch of variables and passed them from within our main level 2 directory. Let's try and see, did I make any errors this time? We forgot to declare an output in our autoscaling group. Let's do this. Yeah, I'm just fixing bunch of misprints, things that I've mistyped. And once this is done, we will successfully run Terraform apply. Okay, very cool. It says argument is deprecated. Use DB name instead. Yeah, let's fix that. It will work right now, but it's just a warning. But however, it's better to have it properly aligned immediately. Let's try again. Okay, very good. We have 3 resources to create. Let's hit yes, and it will take significant time to process these, and perfect opportunity to ask questions. Do you have anything related to what I've showed? Oh, very cool. We have password in clear text. Yeah, Sanjeev, could you please speak up and repeat the same question out loud?
Yeah, so we have sensitive data, right, in the configuration. We need to mask it somehow, right?
Of course, yes. Does it look? Do we mask it good enough right now?
No, not at all.
Yeah. Okay. Yes, of course. And this is what I am about to show you next. Obviously, it's a blender to save any secret information, any password, any token in a clear text, not only in Terraform but in any code. And there is complete, I would say, set of practices called secret management. And we'll get started with secret management as well today in this class. Just after this database instance is created, I will demonstrate. I will not even commit this code right now. We will first fix this issue, and then I will explain how should we handle passwords in our Terraform. And I actually can start some preparations. So there is a service for secret management that is reasonably and obviously named Secrets Manager. Let me delete my previous secret. So I will create a thing called secret. I'll press store new secret. We need choose other type of secret and specify here password. And let me copy paste it to here. Call it, let's say, super secret password 1. So we can notice the difference. Uh, just a second. Yeah, it will not allow me to create the secret with a name that I've previously deleted because it does not delete secrets immediately. So I'll call it main/RDS/password. Okay, we have the secret. We have, no, where it is. Probably I forgot to press save. Let's try once again. Yeah, I forgot to press store. Now we have this main RDS password. We can see the secret value if we would like. If we press retrieve secret value, basically it's I would say managed equivalent, and Sanjeev, you've asked me recently, it's a managed equivalent of HashiCorp Vault. So, and advantage of it, and like any advantage of any AWS service, is that they deal with heavy lifting. So Vault is extremely complicated service that you need to maintain yourself, backup, and make sure it is running smoothly. For Secrets Manager is just an API call to AWS. They are maintaining it for you. They're helping you out by you not having to manage manage encryption keys for it, not having to manage backups. You just store your secret and use it. And yeah, RDS is still creating. Let's wait a couple minutes and simply stare at this window, or we could discuss something else. I could answer any questions that you might have. Yes, Vyacheslav.
Is that Vault more expensive than a Secret Manager?
I'd say yes. For Vault, you need at least several virtual machines. Maybe there is Vault. Let me check. Maybe HashiCorp has created also their own cloud version of Vault. Yeah, they perhaps they can also you can use these like HashiCorp cloud platform and use Vault. It's I would say this. It all depends. Probably cloud version is not that expensive, like manageable. But if you need to self-host Vault, yeah, of course, obviously it will be significantly more expensive. Any other questions? Anything else? Anyone wants to bring something else? Just let me know. Yes, Vyacheslav.
I think I selected today this question. Like on auto scaling, we use the configurations, but why we want to use the templates instead of?
We can use templates as well. Configurations is, I would say, old-fashioned way of doing this. Templates is more modern. They have some features, some fancy features. I would say, if you would like, you can do an extra mile when completing this task and implement it using launch template. It will be helpful for you, definitely.
But
Why
I
not?
guess, using like in a real world environment, the configurations.
In real world environment, both options are currently used. And it's not a dramatic mistake that we're using launch configurations instead of launch templates. It's I would say it is okay it's not that out of date, and the features that launch template is giving, I wouldn't say they are like extremely like game changing and completely new experience or something else. They are very similar. So if you would like, and I encourage you to do so, play with this more, poke into each corner, and it will doing this will be definitely helpful to you.
Thank you.
That's, by the way, that recommendation applied not only to Vyacheslav, but for all of you guys. More you experiment, does not matter if it's this course or something else. More you practice different approaches, more you try different things, more you try breaking things in your lab, more successful you are. Sanjeev, yes.
Yeah, so just for you are showing the high availability for all the EC2 instances, so auto scaling group and those type of things, right? For the web tier, for the database, it's like active passive, right? I mean, read
It's
replica or something.
yeah, there is also read replica, but it's slightly different. In AWS, there are the primary two options for high availability. Multi-AZ deployment. It's proprietary extension, proprietary technology on top of the database engine developed exclusively by AWS. It's a synchronous write. When you connect to DB endpoint of a database hosted on RDS with multi-AZ enabled, your request is automatically on a networking level immediately split into mirrored into two parts and written to two instances at the same time. Reads are happening from one primary instance, but when this primary instance goes down, the second instance immediately picks up even without any replica lag or something, because writes were synchronous and identical to both of them. And second option is read replica, used more like for cross-region disaster recovery and to speed up, to offload, read load from the primary node.
Thank you.
Yes, Sanjeev.
Yeah, just a high kind of thinking out loud, right? If there's a need to migrate to your database to a different region, when you have it's already set up with Terraform, then so we go back to the suggestion that you explained in the previous sessions, right? You just manipulate the state file, correct? I mean, you create the
you
resource.
need to migrate database to a different region.
Mhm.
Am I hearing this right?
Correct, and it's in Terraform already set up with Terraform.
Mm-hmm.
So
Yeah.
what would be the approach to accomplish that? I mean, without breaking or destroying anything, right?
It is very interesting question, because it's like changing a spinning wheel while you're riding a car.
Okay.
What is happening? Database is holding some data inside. There are always reads and writes.
No,
to the
let me clarify, right? I'm not saying like live migration. I'm just saying after shutting down and then properly bringing everything down, we want to migrate with the maintenance.
Okay.
And it's in
Okay.
Terraform. State is in Terraform.
Understood. That simplifies things a little. However, there are still data inside database that should be persisted, I believe. We can't just throw away our passwords of our users and their accounts. We need to do some data migration. If you can afford having downtime, that's great. You just create a database dump and import it into the new instance. But overall, the process is you create new one, No.
My question is more
How I did recently for myself is I created. Let me real quick demonstrate this to you. I created resource AWS DB instance. Let's call it old. It was here before. And in parallel, in the same Terraform state, I created resource AWS DB instance new. That was the setup. Then what we did is stop old. Stop application that connects to old database. It is extremely important step. We want to make sure after we created our dump, no one has written to the old database, so our data is consistent. After that, take DB snapshot. It can be RDS snapshot or MySQL dump, whatever more suitable for you. Then you import your snapshot to new DB. Then you point application to new DB. And after that, you start application, and then simply remove all DB.
So do Terraform destroy for that resource?
No, not Terraform destroy. Remove it from your configuration and Terraform apply, because these two will be together. Anyways, we've managed to occupy ourselves while it was creating, and now it's time to move forward. So what I will do? We need to somehow to read this secret password that we stored in secret manager over here. Does anyone have ideas how we can do this? Any suggestions? I can give you a hint. We already used this a lot in our previous configurations. Yes, this is data source. Very good, Sanjeev. And yeah, there is an opinion about AWS database migration service. It's great that it was helpful for you, Vitor, but sometimes it might not work. Sometimes there are certain database objects, for example, in PostgreSQL, for example, blobs, that not handled by DMS. But alternatively, yes, you can, Sanjeev, you can try using AWS DMS as well. You can consider this option. It's like a replica even without a downtime. And yeah, let's move forward with setting up our data source. It will be data, AWS secrets, AWS secrets manager secret RDS password, and will reference to our password main/RDS/password. And it's a little tricky. We need to obtain both secret with its own ID, and from this secret ID, we need to obtain a version of a secret, because secrets are version controlled. When we write a new value, always stored as a version. Like this. So using this data source, we extracted the secret itself, extracted it so-called secret ID, and then we extracting the latest version of our secret. And RDS password, that's also slightly tricky. Secret manager will return JSON representation, and we need to convert it. We can convert it using the so-called JSON decode function. JSON decode, and no need to worry again regarding these functions. We'll have a separate session talking about them, all of them. So contents of our data source of RDS password and the field called password. And here we can set local.rds password. And let's run Terraform apply. Okay, very good. It says RDS will be updated in place. Password was changed. But anyways, let's edit our secret and have the content here match our actual RDS value. Run Terraform apply again. Not sure why it is saying that it will be updated. Okay, anyways, never mind. Cool, we've created our database. How we actually check it, how we verify that database is present, that database is working, most of all. First, let's see our RDS tab of AWS console. DB instances, one, yeah, here we are, here it is, there we have it. It gives us connection string that we can use. Similar way we connect into load balancer using curl, we can connect using MySQL client to this database from one of our instances. So let's launch our session manager and install MySQL client there and make sure everything works as we expect. That's Ubuntu. So, that's not Ubuntu. Make it more visible. First, I will verify that network connection can be established just on IP level. There is a command called telnet for that purpose. Let's grab our endpoint and 3306 is our port that we need to test. It says connected to, and the host name escape character is blah blah blah. This means we are connected. And sometimes it's stuck our terminal. Come on. If you were to do, for example, telnet, I don't know, 443, it will hang in this string and so on. This means connection cannot be established. Very good. Now let's install the program called MySQL client. No package MySQL client available. Okay, just a second. That's not MySQL client, but just MySQL. Okay. And we can use MySQL to connect to our database. Let's pick the user of our database. What was it? Well, it was admin. And -p means it will ask us to provide the password. Super secret password. Oh, very, very good. So this MySQL none means we are connected to the database. What can we do? Let's see. Okay. Let's try this. Show tables. Not database selected. Show databases. Select database MySQL. Anyways, we are not here to learn MySQL. That's perfectly fine that we were able to connect to this and see this MySQL prompt, and running this command show databases gave us the legit output of the list of database within this RDS instance. That's the accepted criteria. Connect to RDS from our instance and run at least some query. And it does not really matter which one. Let's terminate everything. And let's add everything and commit. And as usual, we should never forget Terraform destroy. Should never forget to run Terraform destroy. And having said that, I'm open the floor